Okay students, let us move to the next session of probability. Let us first have a recall of all the formulas and then move to different types of sums. When I look over here at two events, say A and B, so I have my part over here A and I have my part over here B, where I say the intersection part is added twice. Also, do we say that this part over here, what you see, is only A? Last class we revised only A as A and not B. That means A and not B. That means from A, remove everything that was in B. So my probability of only A taking place is probability of only A taking place is from the full circle of A, remove A intersection B, or from the union, remove full B, leaving you with only A. Similarly, can I say this part over here was only B? Only B means B and not A. That means B and not A. So from B, remove all that was in A. So if I tell you to find probability of only B, that means from B, remove A intersection B, or else from the union, remove full A. Now, let us understand these concepts in the union formula. My probability for A union B, as we recall, is A plus B. That means probability of A plus probability of B minus probability A intersection B. And similarly, you can also write it as only A plus only B, the left side of A, right side of B, plus both, that is A intersection B, where we can use the above formula. What do we recall when I say A and B are mutually exclusive? Well, we say A intersection B is a null set. So if you recall the diagram, this part is A, this part is B. So A intersection B is a null set and my probability of A intersection B is 0. Exhaustive means A and B together have used the full sample space. If this part is A, I can call this part over here as B. That means A union B is my full sample space and my probability of A union B is 1. Mutually exclusive and exhaustive means A intersection B is a null set and A union B is your sample space. Therefore, probability A intersection B is 0 and probability A union B is 1. Do we recall that when we put this formula in our A union B formula, I have probability of A union B, which is 1, gives me probability A plus probability B, and I also define this as disjoint set or partition sets or complement set. Similarly, when I say my events are independent, so probability of A intersection B is probability A into probability B. Now that we've revised all the concepts of the previous class, let us move ahead to sums based on these concepts. My very first sum here says, a mathematics problem is given to 4 students. The odds in favor of candidate A and B, odds in favor of A is 1 is to 3 and that in favor of B is 1 is to 4. What do I mean by odds in favor? Odds in favor means favorable is to unfavorable. So probability of it happening is favorable upon total. So from the given sum, can I say odds in favor of A is 1:3? So probability of student A solving the sum is 1 upon 1 plus 3, and odds in favor of B is 1:4, means 1 upon 1 plus 4. Further, it says odds against C is 5:1 and for D is 6:1. So when I say odds against, it is unfavorable is to favorable. Hence, I again look into the favorable number. So probability of C solving the sum, unfavorable 5, favorable 1, means 1 upon the total 1 plus 5 is 6. And odds for D solving the sum is 1 upon 1 plus 6, which is 7. And hence we say probability of them not solving. So probability of A not solving will be 3/4. Probability of B not solving will be 4/5. Probability of C not solving will be 5/6. And probability of D not solving will be 6/7. The first part of my question here says, find the probability that your problem is solved. Problem is solved means any one of them will solve the problem, or any two will solve the problem, the other two will not, or any three will solve the problem, the fourth one may not, or all four solve the problem. Now, will this not get a little tedious to solve? Pause. What can actually happen? The possibility is one person solves the problem, or two persons solve the problem, or three people solve the problem, or four people solve the problem. That means the problem is solved. There is also one more possibility of no one solving the problem. So do I always know my total probability is 1? So hence I say probability that the problem is solved is 1 minus probability problem not solved. Now, when I say not solved means A does not solve, and B does not solve, and C does not, and D does not. Now, these are three different individuals who are solving the sum. So here I say A, B, C, and D are independent. So this will be 1 minus probability A complement, that is 3/4, into probability B complement, which is 4/5, into probability C complement, into probability D complement. Here my numbers get cancelled and I'm left with 1 minus 3/7, that is 4/7. The second subpart of my question says exactly one of them will solve the problem. Out of 4 people solving, only one will have a success. So probability of exactly one solves the problem is A solves and B does not, C does not, D does not. Or else B solves but A does not, C does not, D does not. Similarly, C solves, A does not, B does not, and D does not. And the last one, D solves, but A, B, and C do not solve the problem. Since they are independent, we quickly open the bracket and substitute the numbers. Probability of A solving is 1/4. B, C, D not solving is 4 by 5, 5 by 6, 6 by 7. Next, in this case, B solves. So A not solving, B solves, C does not, D does not. Similarly, now only C solves. That means A does not, B does not, C solves, D does not. Last one, D gets the right answer. That means A does not, B does not, C does not, but D gets the right answer. So we don't cancel the numbers here for ease of calculation. I keep my denominator same. 4 into 5, 20. 20 into 6, 120. 120 into 7 is 840. And hence I have over here 4 into 5, 20. 20 into 6, 120. 3 into 5, 15. Into 6 is 90. 3 into 4, 12. 12 into 6 is 72. 3 into 4, 12. 12 into 5 is 60. So when we solve this particular number, we have over here 2, 6 and 7 makes it 13, 13 and 9 makes it 22, and 2 makes it 24, carry 2 makes it 342 upon 840, where make sure you write the answer in your least fraction. Let us look at the next sum. My question says, a contractor takes up a job of roof repair and painting for various residential complex. Get the grammar in place. Read, understand, then put a notation. The probability that the company will receive the repair contract, which I'm calling as R, is 2 by 3. The contractor will receive a painting contract, which I'll call as P, is 4 by 9. The probability of receiving at least one is 4 by 5. Now, if you're confused what at least one is, my question says find the probability that the contractor receives both. So, I am defining R as an event of getting over here a repair contract, P over here as a painting contract. My data says probability of getting a repair contract is 2 by 3. Probability of a painting contract is 4 by 9. Probability of at least one, either repair or painting or both, that's a union formula. That over here will be R union P is 4 by 5. If this was a confusion, my question says received both. That means R and P is how much? So when we identify the data, what do we know in this? We know this one formula. Which formula? A union B. So hence, can I say probability of R union P is probability R plus probability P minus probability R intersection P. If I substitute the values over here, 4 by 5 is 2 by 3 plus 4 by 9 minus R intersection P. Shift this over here and minus becomes plus. 2 by 3 and 4 by 9. When I take LCM, multiply 3 down, 3 up, gives me 10 by 9. Minus 4 by 5 comes over here. If I take LCM, I will have 50 minus 36 upon 45, and the probability that the contractor will get both the contracts is 14 upon 45. Only point of concern is identifying the data. Let us look into the next question. No confusion of a word problem. We directly have the data given to us in a symbol form. Probability A union B. Probability A intersection B. Out of the two, do I know any formula? Yes, that is A union B. So we will use A union B formula somewhere. But before that, I have to find A complement plus B complement. Let us decode what is asked. Can I say probability A complement plus probability B complement is actually 1 minus probability A and 1 minus probability B? That is 2 minus outside probability A plus probability B. I don't know these values. Let's go to what I already have in the sum. In the sum, do I know probability A union B can be written as probability A plus probability B minus probability A intersection B. When I put the values, 0.6 is probability A plus probability B minus 0.2. Shift the minus over here, becomes plus. So 0.8 is probability A plus probability B, which I'm now going to substitute here. So hence I have this answer as 2 minus 0.8 gives me 1.2. So probability A complement plus B complement is 1.2. Wait, hold your horse. This probability is crossing 1. We know individual probabilities are between 0 and 1. So is my answer correct? Yes, it is correct. Why? Because I'm adding two probabilities. I'm saying every probability is between 0 and 1. So similarly, their complement also is between 0 and 1. So when I add them, my answer of the complement will be between 0 and 2, and hence this answer is crossing 1. Let's look at the next question. Very important, where we are dealing with three events this time. I have A, B, C as events, given to me the individual formulas, but my area of concern is if probability A union B union C is greater than equal to 0.75. That means it is more than 0.75 till where maximum probability is 1. So we know my answer is between 0.75 and 1. They are telling you to show that one of the probabilities in the answer comes between this range. Let us recall the formula which we did in our grade 11. That is probability A union B union C is you add the single probabilities. That is probability A plus probability B plus probability C. You subtract the intersection of two, that is A intersection B. Let me write that in the next line. Minus probability A intersection B minus probability B intersection C and minus probability A intersection C. And you add the triple probabilities, that is probability A intersection B intersection C. So I know that this answer is greater than equal to 0.75 and less than 1. So can I say this entire answer will lie between 0.75 and 1? So 0.75 less than equal to and 1. So if I substitute the values over here, my probability of A is 0.3, probability of B is 0.4, probability of C is 0.8, minus A intersection B is 0.08, B intersection C is what I want to find, A intersection C is 0.28. And my probability of the triple intersection is 0.09. So Very carefully over here, can I say 0.75? Now 3 and 4 7, 7 and 8 is 15, so 1.5. With this 0.09 is 1.59 minus 0.08, and 0.28 over here becomes 0.36 minus probability B intersection C less than equal to 1. 1.59 minus 1 minus 0.36 gives me over here 1.23 minus probability B intersection C less than equal to 1. Now very carefully students, if I have to solve this particular part, I am moving 1.23 over here, which leaves me with 0.75 minus 1.23 over here minus probability B intersection C, and over there 1 minus 1.23. So 0.75 minus 1.23 gives me over here 25 and 23, that is 48, minus 0.48 minus probability B intersection C minus 0.23. So do we say minus minus cancel? No. Two reasons. It is an inequality. And even if you go ahead to cancel, you will have 0.48 is less than 0.23, which is not in ascending order. Means I am going to multiply everything with minus 1, and when we do that, the sign of the inequality will reverse. So 0.48 reverse sign B intersection C reverse sign 0.23, which if I write in an ascending order is 0.23 less than equal to B intersection C is less than 0.48, and therefore I say probability B intersection C lies between the interval which is inclusive, and therefore a box bracket 0.23 comma 0.48. A very very important sum, not usually asked, but it is good to know. Let's look into the next sum. Now I'm going for more than one selection. You have a box. The box contains 30 bolts and 40 nuts. Half of the bolts and half of the nuts are rusted. Let us first get this diagram. I have a box which has 30 bolts and 40 nuts. Now, my question says half of the bolts and nuts are rusted. That means I have 15 rusted bolts and I have 20 rusted nuts. Now read the question. Two items are drawn at random. You are selecting two items from the box. Find the probability that both are rusted or both are bolts. What are you interested in? You are interested either in a rusted item or you're interested in bolt. So let's define. R is an event, selected item is rusted, and B is an event, selected item is bolt. That means if I say this is your rusted part and this over here is bolt, this part is considered twice. Isn't this your union concept? My question says find probability that either both are rusted or bolt. So probability R union B, that is probability of R plus probability of B minus probability R intersection B. Now you are selecting two items very carefully. totally how many rusted items are there in your bag? There is a rusted bolt and there is a rusted nut. That is 35. That means from 35 you select 2. Then how many bolts are there in the bag? 30. So from 30 you select 2. Now this part was considered twice, rusted and bolt, that is 15, you select 2. And your sample space is your total box had 70 items, that means from 70 you select 2. So now when you use these values in your concept of combination, you can use your direct formula or you can use your calculator method, but by entering the values correctly in the calculator, only then you can get to the answer. Please note, when you're using the calculator, preferable to use these values in a bracket to get the right answer, or solve the full numerator, then divide by the denominator value to get the least fraction. Let us look into the next sum. My next concept says A, B, and C are three keyword mutually exclusive and exhaustive events, means nothing in common, have used the full sample space completely. Just a rough diagram, I can have them like this. If this part is A, this part is B, this part is C. Find all the respective probabilities for the given data. So I have over here probability of B is 3 upon 2 probability A, and probability of C is half probability B. Can I say let probability of A be P, hence probability of B will be 3P upon 2, and hence probability of C will be half into 3P upon 2, which is 3P by 4. Since they are mutually exclusive and exhaustive, can I say probability A union B union C is probability A plus probability B plus probability C, which we know is 1. So 1 is equal to probability A. Probability B is 3P upon 2 and probability C is 3P upon 4. On taking LCM, I have 4P plus 6P plus 3P upon 4, which gives me over here 13P by 4 is 1, and hence my value of P is 4 upon 13. So if I take this part over here further, they are telling me to find all the probabilities. So do I know probability of A, which is P, which will be 4 by 13? Probability of B, which we have defined as 3P by 2, that is 3 by 2 and 4 by 13, gives me over here 6 by 13. And probability C, which you've defined as 3P by 4, leaves me over here with 3 by 13. If you observe, this answer is adding to 1. Hence, your calculation is correct. Let us look at the last question. Now, in a class of 60 students, in your school there are 60 students, for a co-curricular enrichment, 30 of your classmates have enrolled for cricket, 32 have enrolled for a pickleball game, and 24 have enrolled for both. During an inter-school competition, one of the classmates is selected at random. Find the probability. We'll read that part later. First, let us define the event. There are two games involved over here. So can I say C is an event that a student is participating in cricket? P is an event that the student is participating in pickleball. So what is given to me? There are total 60 students in class. So my n of s is 60. So probability that a student participated in cricket is 30 out of 60. I am not cancelling this. I'm keeping the denominator as it is for ease of calculation. Probability that a student participated in pickleball is 32 out of 60. And there are 24 students who have participated in both. So probability of C intersection P is 24 upon 60. Now, what does my question say? A student is selected at random. Find the probability the student opted for cricket or football. When I say or, I use union. So, probability cricket or pickleball, sorry. So, that will be probability cricket plus probability pickleball minus probability cricket intersection pickleball. That will be 30 plus 32 minus 24 upon 60. That gives me the answer over here as 30 plus 32. 32 minus 24 over here is 8. And so I'm left over here with 38 by 60. Make sure you write the answer in your least fraction or your decimal values, which over here will become 19 by 30. Now, my next part of the question says, the student has opted neither cricket nor pickleball. Look at this part very carefully. The student has taken neither cricket nor pickleball. They did not take cricket and they have not taken a pickleball. That means they are outside your Venn diagram. Using your De Morgan's law, can I write this as C union P, the whole complement? That is 1 minus probability C union P, which you already know is 19 by 30. So 1 minus 19 by 30 is 11 by 30. Let's look at the last part. My last part says the student has opted for pickleball but not cricket. So student has opted for pickleball and not cricket. Can I say this is only pickleball? Only pickleball means P from the entire pickleball. You remove P intersection C. So probability of pickleball was 32 by 60 minus probability P intersection C, which is 24 by 60, leaves me over here with 8 by 60. Now, if in case you think remembering formulas is a challenge, let us look at the same question for a proper recall in the form of a Venn diagram. I have my sample space over here. Under that, I have students who are participating in cricket and I have students who are participating in pickleball. Now, I know for cricket, there are totally 30 students. For pickleball, there are 32 students. And I know there are 24 who have opted for both. So, if I say for this particular part, if I want only cricket will be 30 minus 24, which is 6. For only pickleball will be 32 minus 24, which is 8. And hence, I verify my answer. 6, 24 and 8 adds to 38, which my answer here is correct. When I say only pickleball, that value over here is 8, which matches, which in the least fraction you will write over here as 2 by 15. And when you know the both circles are adding to 38, so students who've not opted for pickleball and for cricket, From 60, if I remove that, I'm left outside with 22, which is coming over here to 11 by 30. So watch it carefully, understand the word problem, define the given data, and hence solve these questions very carefully. In the next lectures, we will deal with more higher concepts of probability. Thank you.